Let's start our today's class and the method of the expressing 3D with 2D data. Okay, so for today's data, and you could download it on the Google Drive, and I'm going to look at. Okay, and now I have give you guys the data and the punching QR code and the quiz QR code. So you could scan this punching QR code and download the data from the Google Drive and to take the questions in the quiz to listen our class, to listen our course. Okay, so you could download our data before our class. Okay, and then let's start it our today's class. The method of the expressing 3D with 2D data. So we have accumulated. Yeah, we have accumulated a wealth of the 2D GS data. So if this 2D data in the past are completely discarded and the new 3D GIS data are reproduced, so it will cause a great waste, right? So if the existing 2D GIS data can be extracted, converted, or reorganized to establish the 3D visual environment, then the 2D GIS data is undoubtedly a rich and a low-cost data source. So, how to use the existing 2D vector data to construct a 3D scene? There have the two ideas. The first is do not change the data itself and directly add the 2D data to the 3D scene and render them through the 3D layer to make them show as a 3D effect. So in the 3D scene, we can. So in the 3D scene, we can assign and the elevation to the 2D point line and the polygons, and then use the 3D symbols to express them. Use the 3D symbols to express the 2D point line and the polygon. So the polygon refers to the water surface. So we just to do the water as to use the 3D symbols to express the polygon of the water. Okay, so that is the first method to express the 2D data through the 3D layers. And then for the line and the polygon, and it can also be especially and dynamically to stretched to become a 3D model, and then set its texture set the texture to obtain the realistic 3D model. So we could dynamically stretch the 2D data and set the texture of the line and polygon. Okay, that's when we do not change the data and directly add the 2D data to the 3D scenes. Okay, so if we have the elevation of the 2D data, we could just update the 2D data to the 3D data. There have the three methods to do these options. The first is specify the elevation value to realize the upgrade to the 3D data. After we convert the 2D data into the real 3D data, and it is added to the scene for the expression. And then we could convert the elevation attribute of the 2D points, lines, and polygon into the Z coordinates, and the 2D data can be upgraded to the 3D data. And then our second method, it is also possible to extract the elevation from the terrain data, from the DEM data, or the oblique photographic model data in the same area to enhance the 2D data. Okay, and last, if you give the 2D data the elevation of the polygon, and then you could linearly stretch and map it to the generate 3D solid the intended model. So what's the difference of this method and this stretch and texture method? That is, for the stretch and the texture of the lines and polygons, it's just to dynamically to stretch our data. And if we give the elevation to our 2D data, that is, we modified its Z coordinates, modified its Z value, and to generate a 3D solid model, to generate the model data in our at desktop. So that is a method to compress the 2D data to the 3D data. And then let's look at this method and to do our exercise. So first, let's look at the 3D symbolic rendering. So that is the simplest operations of the rendering 2D data to the 3D data. We use the symbolic rendering. And regardless of whether the data itself has the elevation, that is to see the 2D and 3D points, line, and polygon can be rendered in this way. So the points in the pictures, so in these pictures, and it includes street lights, and the trees, and the road, and the lines include the road, and the surface and the polygon includes these two types of the buildings, and it could generate the water surface. Okay, and how to do this operations of the 3D symbolic rendering? We have the two steps. the first step is adjust the height mode. So we could add our data and set it a style setting and set it a height mode and choose the non-ground and set it a bottom elevation. And then we could just directly render or generate a 3D semantic map. We could right-click over a selected layer and select its layer styles and select its style settings. Or we could we can make the semantic map and select its items and to modify its style. Okay, so let's do this exercise to look at how to do the 3D symbolic rendering. That is our first exercise in today's course. So for the data, we could use the symbol.udbx. And then we are gonna to do the straight line to modify the roads, the water, and the data site of the trees to generate the semantic map. Okay, let's open our super map at desktop. Okay, open the super map at desktop and let's close this workspace. And to open the data that I have give to you, to select the data from the method of the expressing 3D with a 2D data, and to select the 2D to 3D, and select this 3D scene.smw. It's in the method of the expressing 3D with a 2D data, and in the folder of the 2D to 3D and the 2D to 3D to select the 3D scene.smw. Now let me zoom in it. Okay. In the method of the expressing 3D with a 2D data and 2D to 3D, and to select the 3D scene.smw. Okay, select this data. And there have the 3 data sites. And let's find the symbol data sites. Oh, before our exercise, I'm gonna to show you that the 2D map and the 3D scene, that is the same data. We could see. And the 3D scene, let's open this 3D scene. We can see that is the same data. For this 3D scene, maybe there don't have some data, so that doesn't matter. That is a 2D map, and that is a 3D scene, and it's use the same data of the 2D vector data. And we could use this 2D vector data and to do some operations and to express to the 3D. Okay, so So in this course, and you will learn how to convert and extract the elevation of the 2D data and convert it to the 3D data. Okay, that is a result of our data of this course. So let's open the symbol. Let's open the symbol data site. Open the symbol data site and and find the straight line, and now let's zoom in our window. Okay, find the straight line, and the road, and the water. So these 3 data sites, find the road, water, and straight line, and right click, add this to new surface scene. Add this. Okay. And in the layer manager, let's zoom it to the layer. Zoom it to the layer and modify its terms in our layer manager to let the point data site as a top of our list. The point data site and the line data site and the polygon data site. Okay, and we can see that is our this is the road, and this point is a straight line, and that is a water. So let's look at how to modify it and to the 3D thing and modify it and express it as a 3D data. Okay, so first, let's select the straight line. That's it. Okay, select the straight line. Select this and find in the tab of the straight settings. In the tab of the style settings, and to modify its altitude mode. In the extension settings, modified its altitude mode, and select the relative to the ground. We could see there have the 4 modes. There have the 4 modes of the collapse to the ground and absolute, and relative to ground and collapse to object. There have the 4 modes, and let's select one, and later I will introduce you what are these 4 modes means. Okay, let's select the relative to ground, and modify its altitude as 4. Modified it as 4. Okay, and then let's look at our 3D scene. We could see that we give it the height. We give it the elevation, the height elevation, and it's upper to our terrain. And then let's right-click the straight line. Right-click the straight line and select the layer style. Select the layer style. And let's select the 3D symbol. And there have some 3D symbol. We could choose, and let's choose a straight line. straight line. Select the straight line and modified its scale, modified it as 2. And if we modify the 1 parameters, then this 3 parameters will change. Will be changed and select it to the 4. To select in the 3D symbol and in the straight line, 3D symbol, straight line, and modify its scale and click apply. Oh, and click OK. Oh, and let's right click it and zoom it to the layer. Oh, we could see the straight line is in our 3D scene. So that is from the 2D point to a straight line. The way that is that we modify the altitude mode and modify its altitude. So what's the meaning of this 3 mode? Of these 4 modes? Okay, and let me introduce you it. It's in there. Okay, that is our help document. Our help document of the altitude moves of our help. So let's look at there have these 4 moves. And sorry. Okay, so for our first is a collapse to the ground. So according to the data source, there have the ground data and the underground data. So for the ground data, let me introduce you the ground data first. There has the first mode is the collapse to the ground. So we can see this mode its elevation height of the 3D data will be ignored completely. So each 3D objects attached to the terrain surface according to the latitude and the longitude and the terrain fluctuations, and it's shown as the following figure. When use a collapse to the ground mode, and the elevation height information of the raging objects is ignored. So we could see if we have some data and if we set it a collapse to the ground, and it will have the elevation and it's depends on our terrain data. So that is a collapse to the ground. And the collapse to the ground is a default height mode. So, and you can not set whether the data comes from the ground or the underground. And absolute altitude. And the absolute altitude is the height relative to the sea level. It's relative to the sea level. So if we set this absolute altitude and give it the height, give it to the altitude, and it will depend on our sea level. And this mode ignores the terrain real altitude. And when we know the exact altitude, and it is useful. So as shown in the following figure, and the border news of the raging objects in the scene are 5,800 meters, and then use the absolute, the display status of the region is as shown below. Okay, that is the absolute altitude. It depends on the sea level. And for the relative to the ground, the altitude in the relative to ground mode is height relative to the terrain surface and the longitude coordinate values. As shown in the figure below, a line object is the same and the elevation of each node is the same. So the display status is as shown in the relative to the node. So if we have the data, and if you want to, your data is displayed as in the shown below, you could select the relative to ground. And that is depends on your mood, depends on your terrain data, the coordinate system. Okay, so if you give it the height, and it will up to your terrain data, to your DEM data. And there also has the mode of the collapse to the object. And when we use the collapse to the object, the vector data will collapse to your terrain or your oblique photograph. And as shown in the below, and the elevation information will be ignored and collapse to the terrain model data. If collapse to the object mode has been employed, and the collapse to the object altitude mode often applies to the oblique photography model is seen. So if you have your data, your model data, and you could set it a collapse to the object, and that will apply in your urban plan. If you're establish your house vector data, and you could set it to collapse to the object, and it will collapse to your oblique photograph object, and you could set its the level information, the level altitude, and or something. And there have another mode to modify the terrain. So that is often used to terrain in the vector region area. So if the model and the terrain don't match well, and you can flatten or raise the terrain to make the terrain and the model match. And you could use this modified terrain mode. Okay, that is this 4 moves of about the altitude moves. Okay, so there have some notes. There have some tips, and there are also the question in our quiz. There are also the question in our quiz. So if you want to modify your altitude, modify your height of the elevation, and you could set what mood in the below. And the answer is absolute altitude and the relative to ground and collapse to the object. So why does we to set the collapse to the ground? The reason is collapse to the ground is depend on our terrain data. So we could not set the height, set the elevation, the altitude of the mode in the collapse to the ground. So if you want to set its height, set its altitude, you could select these 2 moves, these 3 moves. Oh, it's too slow. 有人上来。啊？没有断啊。 那我不能再开始了呀，有关系吗？嗯。哦，好了好了，可以，我又开始。Okay. Okay, and let's do our next step and to set our road, to set the altitude mode of the road. Okay, and then let's select the road and modify its altitude mode as relative to ground and set its altitude to the 4. And then let's set all the layer style of the road. Set the layer style of the road to the 3D line. And there have the railway in the 3D line, and the line library, there have the railway. Now let's zoom in it. Okay, in the 3D line, there have the line library, and let's choose the railway. Okay, and let's modify our wax to the 20. Select the 3D line and in the railway and modify its wax and click OK. We could see it will modify to the railway in our 3D scene. Okay, so maybe I set the railway. Let's click the layer style, and we don't set it railway, is in highway. Select the highway of our lines of our line symbol. Select the highway. Okay, in our scene, we should set its highway in our 3D scene. So that is a point line, and there have the water polygon in our 3D scene, and let's set our water. So for the water, and if you wanted to set its rendering effect, you must to modify it to the relative to ground, and it will be displayed in our 3D scene. And then let's modify it to the 4. Look at it in the style settings and modify its altitude mode to the relative and modify its altitude. And then let's right click the water and click the layer style and select the 3D file, 3D file, and select the still water or clam lake. Let's select the clam lake and click OK. We could see it will appear that that's the effect of the 3D symbol of our surface of the water. So that is a step to do the symbolic of the 3D scene. Okay, and then let's add the tree. in the symbol, let's find the tree in our symbol. Right-click it and add to the spherical scene. Not new spherical scene, that's the current spherical scene. Right-click it, add to the current spherical scene. Okay, we could see the 2D tree, the point of the 2D data will appear in our 3D scene. And let me introduce you our second method to express the 2D data to the 3D data using the symbolic, using the 3D symbol. That is to do the semantic map, to create the semantic map. That is in the layer manager. In the layer manager, and right-click the tree, and that is the create the semantic map. Click the create the semantic map. It will display this window, this prompt window. It's a create the semantic map, and let's select the unique values map. Unique values map, and select the default and click OK. Let's right-click it and create a semantic map and click OK. Let's look at what happened with this. Okay. And maybe it's a little slow, and right-click the tree and create the semantic map. It will appear that the semantic mapping flow window, and let's to do the unique semantic map of the tree. And so first, let's select the unique expressions as the species of the tree. That is the attribute column of these trees, and it has the coniferous tree and the tropical tree and the willow. So we could set this types of the trees to use a unique semantic map. And let's to select one, select the first trees, and to select this settings button, the texture settings. Select the styles button. The styles. Let's zoom in this. Select one attribute and select the styles, and click the dot style. Click the dot style. It will display this appear this marker symbol selector, and the step is same like to the first to select the tree. Okay, there just have the one tree. So let's look at it. Okay, in the, I don't know whether you have this library, this marker library. If you don't have, you could import. You could import the symbol library, and I have give you the 3D library in there, in the 3D library, and to find the tree, or you could select the marker library. Okay, you could just to open the tree library. And we could click OK. It's just the same trees. So I have the point of the trees in English. Let me find it. Let me find it. I think I have this in English. Let me look at it. Okay, so they don't have markers in English, and you could to look at this pictures, this figure to select the tree. Okay, so first, let's select the tree that you like. And so for our first tree, we could select this and click OK. Oh, don't forget to modify its scale to 4. Okay, to click it and click the style and select the tree and to modify its scale to the 4. And it will more bigger. And then select another tree, click the dot style and select the other tree. You could select in the 3D symbol and there have the tree. Okay. And click the 4. Click OK. And then we could select this willow. Oh, willow. We could select this tree. Let me find the tree. Import it. Yes. Okay, it's in the marker library and in this, you could select the tree and we can select this tree and modify its scale. So you could select everything that you like. Okay, this is to do the semantic maps and to set its styles, and that applies to if you have the different attributes of your species of the types of your data, you could to set the semantic map to set its style in our 3D scene. Okay, so that is step 2 of our first exercise. Okay, and let me come back to our PowerPoint. Okay, I have come back to my PowerPoint, and that is our first exercise to use a 3D symbol rendering and to render the street map, the road, and the water, and to make the unique semantic map to do this tree. That's our first exercise. Okay, and then let's do our next exercise to do the stretch modeling. Use vector data. That is when we do this exercise, we should do some preparations for this exercise. And this preparation I have done for you. So let me introduce you these preparations. So the first step, you should collect the data. That means you could make or obtain your building vector data set and to import the supermap at desktop. And then you should get the texture. You could to shouting or the download in the internet, and it includes the building texture materials online. And then you should edit your image. It includes create the texture or adjust the angle, reduce the pixels or something in the software like the Photoshop or some another software. Okay, and then the first step, that is you should to add a field in your data, and it includes bottom elevation, that is lift altitude of the buildings, and the stretch height and your elevation, your altitude in your field. So that is a step 2 as a field. And then you should edit your data and save your data. So that is a 5th step. And the texture, so you should pay attention to this. The texture path is generally a relative path, and that is the path of the texture file is relative to your workspace file. So when you're when you're set your texture file, and you should to edit in your behind your workspace and set it as a relative path. So let us look at our data first. Okay, let's look at my okay, let's look at our desktop. And then for the example, and I'm going to let you look at this building 1. No, building 2. Okay, for this building 2, so first we should to add this building to our desktop, and let's look at its attribute table. It has this buildings tab and lift height, altitude, and horizontal tiling and vertical tiling, and it's set texture and top texture. So that is it's a relative path of the set texture and top texture. And let's look at this texture. It's in there in our data file, and there has a folder of the texture. Oh, there don't have. my, okay. Okay, so let's look at this altitude in this building 2. Click this building 2 and right click to browse its attribute table, and there have its a tab and the lift height and the altitude, and it's a horizontal tiling, vertical tiling, and the side texture and top texture. And this texture is a relative path. And where is this texture? It's in our data folder. There has a folder of the texture, and that is some pictures of our buildings. So that is the texture of India's buildings. We could see that this path is relative to our workspace. So it's in texture, and there is our image name. Okay, so that is our data. Okay, and then let's look at how to do our exercise 2. Okay, and I'm going to come back to our PowerPoint. So this exercise is to dynamic stretching the operation method. So after the preparation of our data, we can do this dynamic stretching, which is also divided into 5 steps. Okay, this 5 step is also our questions in the quiz, so you should pay attention for these 5 steps. So the first is to add the data. Add the data that you have prepared. And secondly, to modify the height mode of the layer under the style settings menu. That is in the style settings, height, altitude mode, and to select its absolute height or the relative to the ground mode. And the altitude mode depends on whether the data used is the actual measured altitude value or the altitude value relative to our ground. So that's mode that I have introduced you before. Okay, and the third step is to set the value of the bottom elevation. That is in the style settings, and this is change its name. It's a lift altitude, and to select the field that we have done, that we have added in our data, and then when we manually entering your level, and all objects in the layer have the same bottom elevation. So if we set its altitude, and it will have the same bottom elevation. And when we taking the values from the fields, and the elevation values of the objects in the layer can be different. So what's that? It means let's look at our desktop. Okay, and then let's look at if we just set its style settings. Where is the style settings? In there. If we just set its style settings, select our last exercise. We just to set all of its lift height. So if we set it to use this attribute table to use this field, and we could set its make it different. Like we wanted to set our the high res rooftop as 30, or set its upper wall of the high rise office buildings as 60. So that is could to make its altitude different, make its lift height different. Okay, that is a method. And let's come back to the PowerPoint. Okay, that is a third step, is to set the height value, the lift value, lift altitude. Okay, and the first step is to set the stretch height. Is to set its stretch height. And so it's just to set the value and to modify its stretch height. And I think it's really simple, and I will in demonstration to you. And then to set the texture. Okay, the set the texture, that is to set your side texture and the top texture respectively, and their horizontal and the vertical direction. You could also set it. Okay, and then let's look at, let's do our second exercise. And we will use the same UDBX, the same data source, and use a folder of the texture. And then we will do these three data sets. First is the fence. We could achieve its stretching modeling, and the building 2, and the building 1 to is the same like the tree to generate the unique semantic map, and then stretch the modeling. Okay, let's do our second exercise, and open the desktop. Open our desktop. Okay, I have opened it, and then we could use this. We could just use this 3D scene, and then let's add the fence in the symbol. Let's find the fence. Okay, in there. Add this fence. Okay. It's a little slow. Okay, as a fence, and drag it to our 3D scene. Okay, and let's zoom in it. It's in there, fence, and drag it to the 3D scene. Okay, and then we could see there are the 2D lines, and then let's modify its altitude as a last step, our first exercise, and to select its style settings. Select the tab of the style settings, and select its relative to ground. Select the mood to the relative to ground. Yeah, relative to ground, and altitude set it as 4. Relative to ground and set it to 4. And let's select the texture settings. The texture settings in the extension settings. And then let's set the texture of the fence. Select its texture file. Select the field of the texture file, and select the real size. The repeat mode as the real size, and the U size is a horizontal tiling, and the V size is a vertical size. Okay, and let's look at our fence. Okay, and let's me look at altitude. Okay, and then let's refresh it. Refresh it. Select its texture. Okay. Where is our mouse? Select its texture file. Let's look at it. Texture. Is it works? Let's look at it. Okay, what's wrong with it? Real size. So let's click it. Now let's look at this fence. I have seen in the chat box, should the fence collapse to the ground or relative to ground? Yeah, I have set its altitude to relative to ground. And maybe its texture file is not appeared. I don't know why. And let's look at its texture file. Its fence is in there, and okay, so maybe it's have some problems, and let's do it. Let's repeat our steps, and let's add our fence to a new spherical scene, and let's look at what's this? Okay, and then that is a fence. That is our fence, and then add it to the spherical scene. I'm not able to edit it because there are no 3D single. Okay, for this question, it is in, I have give you to the, in this folder, in the 3D library folder, okay? Okay, and then let's repeat our steps. Do it again. Click our data and to modify its style settings, and click its relative ground, click to 4, or if you, and click the texture file and select the texture file, select the real size, select it to vertical. Okay, I don't know why. Altitude, leaf height. Altitude is the leaf height to the 4. Okay, yeah. So, yeah, thank you. Thank you, our friends. So I forgot to modify its leaf height. Yeah, I forgot to modify its leaf height. So we should we should change its altitude and the lift height as a 4, and it works. It's to the to this fence. Okay, thank you very much. Thank you. Yeah, old version is the extend attitude. Right. Okay. So let's do it in our 3D scene. Select this fence. Okay, so let's do it again. So first, find the fence in the symbol data site and drag it to our 3D scene. And in the layer manager, and we could select the style settings, and click it altitude mode to the relative to ground, and select its altitude to the 4, and modify its lift height to the 4. Okay, and then modify its texture settings to click this button to change its texture settings, and to select it as a texture file and select its real size. It's a repeat mode, it's a real size, and select its U size and the V size by click this field. Okay, and then it will appear and it will symbolize its fence. Okay, that is our fence, and then let's do some exercise to our building 2. In the symbol, in the data size of the symbol, and find the data size of the building 2 and drag it to our 3D scene. Okay, and we could see that is our building. That is the building, and let's do the same step of the fence. So first, modify its style settings. Oh, yeah. Okay. Good job. You can do it. And then select the tab of the style settings and select it to the relative to ground, and to modify its altitude in the field, modify its altitude in the field, and modify its lift height. Okay, select its altitude mode and the fields of the altitude and the lift height of the lift height. And then we could see that is just a model, and we can texture this building. And by click this texture settings and modify its side texture and the top texture. Okay, and let's select its texture file. Okay, because let's look at our building 2. There have the set texture, but we can't see it in this texture manager, right? So why does it? Why is oh, we have seen it. Oh, that is a set texture. Yeah. So that I want to talk to you is to click this properties and to look at its our attribute table, to look at our properties of the attribute table. So if you want to look at your side textures, you must to modify its tab to the text. To modify your text of the texture to the text, to the tab of the text, then you could see it in this texture manager. Where's the texture manager? Oh, in this texture manager. So this fields will be the tab of the text. Okay, so let's select the side texture. Select the texture file as a set texture and change its repeat mode as a real size and select its U size and V size and select its top texture and the real size and the U size and the V size. Okay, we could see that is the step of the to dynamic stretching our model. Okay, let's look at it, zoom in it, and for the 3D texture manager, select is a side texture and repeat mode is a real size. And the U size is a horizontal tiling and the V size of vertical tiling. And the top texture is a top texture and the real size and the horizontal and the vertical. Okay, that is the step is to set our building. Okay, we could see that is a little yellow. The color is a little yellow, so that's the reason is let's right click it and click the layer style. Its foreground color is yellow, so we can set it to white and set all the symbol, the line symbol as a none. Click OK. It will modify its color to the red color. And that is our how to dynamically stretching our building. Okay, and then let's look at how to make a semantic map and to do this stretch modeling operations. Okay, and then let's find the building one. The building one. And it's in the single data set. It's in the single data set. And right click it to the current scene. Here we could see it's appearing in our data. Okay, that is our building one. And let's look at its attribute file first. This is in Chinese, so they have some spaces of its wall. It includes the top and the side and the hall, and that is escape roads and the wall. So it means it have lots of tabs of your properties. So we could to generate the semantic map to modify its tab to depend to through this tab and to do the semantic map. So let's do it. Let's do it now in our layer manager, and right click the building one. Click create semantic map. Let's look at it in the layer manager and select the building one, right click it, and there have the create semantic map. Create semantic map. And then click the unique map, unique values map, and click the default. Click OK to generate a unique semantic map. And then let's select the wall properties. Select the wall properties. Okay, there have some tabs of the wall, and it is in English. And let's look at it. That is a bottom axis. Yeah, so that is in English. So I will change its title to the English. It's a site. That is a wall. It's just a simple translation. So that is its aspect. It's oh, okay. That is the tabs of the wall. That is the tabs of our building, and we can set it in the different styles. Okay, that is the same step as the tree. Let's select one field, and select the styles. Oh no, select it's the setting button, the texture settings. Okay, select one and select the texture settings. It will appear this semantic map item. Okay, and let me repeat it. It's a step. Select one, select this bottom axis, and select the texture settings button. Okay, and to modify its item property, to modify its extensive property as an item property, and modified its altitude mode as relative to ground. Relative to ground. And then its data form is a ground. And modify its lifted 103. Modify its 103 and to select the set texture, select the side texture. It's a set texture. Let me find it. Set it as a building 10. Building 10. Yeah. Set it a building 10. And select its repeat time as a real size. And set is 15. That is 8. And the texture file is ground 1. The top is a ground 1, and the repeat mode is a real size, and that is a property. And select its altitude mode as relative to ground. And its data form is ground, and fill mode is a fill and outline. And modify its lift height as a 103. And its side texture is a building 10. Side texture is a building 10. And repeat mode is a real size, and U size is 50. Is go round 1. Okay, let's click OK. Okay, and we can see that is our bottom axis. And then let's modify to another parameters. So that may be it's a little. Okay, let's modify it. The side, and maybe I will to do it more quickly because of our time. So, and let's modify it. Lift it as 101. Okay, select it. It's also building 10 and the real size 18 and 8. And that is a ground 1. Repeat time. Okay, now click OK. And then modify the wall. And relative to ground. And set it to 100. Its texture is ground 9. It's a ground 9. And its real size is 45 and 15. So if you're not following me, it's okay. You just choose modify its bottom axis. That is good. So, and let me change it to 100 and ground 9. Granite. Building 4 as a building 4 in Cleveland. No. It's like it says building 4 and building 1. Building 1. Okay, that is our and modify its foreground and apply. Okay, this is just a demonstrate to modify to generate a semantic map. So if you just to do the bottom exercise, I think you are good. Okay, and then that is our exercise 2. Okay, and then let's look at our next exercise. Okay. Let's look at our next exercise. That is to the 2D data upgrade. The 2D data upgrade, and it has three. It has a 3 method to do it. That is the first is if you have the 2D data, and if you have the elevation value, and you could to do the data type conversions to convert it from the 2D data to the 3D data. And if you have the and if you have the 2D data and the terrain data and the oblique photography model, and you could extract the 3D data. And if you just have the 2D data, and that is the polygon data, and you could do the linear stretch modeling. So let's do this 3 exercise. The first is a data type conversion. That is really simple, and let's do it. Okay, let me open our desktop. Open the desktop and find one point as a trash can. Find a trash can and add it to the current scene. Okay, and modify. Let's look at. Let's add it to the news frequency. And zoom it to the layer. Okay, we could see that is a trash can, and let's convert it to the 3D point. That is in the tab of the data, and select the conversation, and select the 2D point to the 3D point. Okay, and there will appear this window, the 2D point to the 3D point. And then let's modify its z coordinates as a 4. We just to that is a trash can, and we could modify its z coordinates as a 4 and click the convert. And let's add it to our current scene. We can see that is a 3D data of the trash can. That is a symbol of the 3D data. And let's look at it. The 3D data has its altitude, and it's different from our 2D data. So if you have the elevation, you could use this conversion to convert the 2D point to the 3D point, or to convert the 2D line to the polygon to the 3D data. Okay, that is our first method. That is the first method, and let's come back to the PowerPoint and look like. Okay, the second is if you have the terrain data or the oblique photograph data, you could extract the 3D data. And the function is in the spatial analysis and in the surface analysis and extracting 3D data. And for the oblique photograph, you could click this 3D data, oblique photograph, and extract 3D data to the extracted data. Okay, and then for this exercise, and I will use terrain data as an example to extract the 3D line. So we could use Chongqing.udb, and then let's open our desktop. Open the desktop. Okay, and then I'm going to close this window. Close this window. No. Okay, and then to find the Chongqing.udb in our data site. Okay, there is a Chongqing.udb, and let's add this DM added to the new spherical scene, and add it as a terrain and image, and click OK. Okay, and let's right-click it and zoom it to the layer, and let's add the extract data as a new data site. Okay, we could see that is the road. That is the road in the terrain data, and its altitude mode is clamp to ground. And if we modified it as absolute, we can't see this road. So if we click the layer manager and to right click to invisible our DM data, and we will see our route. So it's under our terrain data. So it's under our terrain data. Okay, so in this exercise, we will to use the terrain data and to extract the z value to our line. Okay, and let's look at how to do it. Click the spatial analysis. Click the spatial analysis, and in the raster analysis, the spatial analysis, and in the raster analysis, there has the surface analysis. And let's find the extracting 3D data. It's in the group of the extract lines, and there have the extracting 3D data. And For the DEM data, let's select the DEM. And for the 2D vector data, select this new data site. Would you send me this material through my email? Okay, I will send you it after our class. Okay, that is extract 3D vector data. And then that is there have the parameters of the elevation scaling factor and the interpolation of the exacting news only for the line. So let's don't need to be change these parameters and click OK to create the new dataset 3D. Click OK and wait a minute. Okay, and then wait a minute. So let me explain you these two parameters. The first is the elevation scaling factor. This value is refers to the unit conversions factor of the grid value, includes the z coordinates, that is the elevation value, and the relative to the x and y coordinates in the DEM grid. Usually in calculations where x, y, and z are all involved, it is necessary to multiply the elevation value by an elevation scaling factors to make these three units consistent. So for example, the unit in the x and y directions is meters, and the unit of the z direction is feet. So since 1 foot is equal to the 0.3 meters, so you need to specify a zoom factor of the 0.3. The 0.3. So if it's set to 1, it means no scaling. Okay, and it's successfully to generate this new data set 3D, and let's drag it to our current window. And let's look at if we set its style setting as absolute, and it's always to appear in our 3D scene. Okay, and it's extract the terrain's z value to this 3D to this 3D line, and let's add it to the new map to look at its z value. Add it to the new map and select it. In the map, there have the select button, and select it and right click, click the properties, and in the flow window, there has a news. Let's look at its news information, and there have the z value in this news. So it's extract the terrain's z values to this 3D line. Okay, that is extract of the 3D line. Okay, and so that is our third exercise. And let's go back to our PowerPoint. And this is our third exercise. And then let's do our next exercise. It's the linear stretch modeling. So linear stretch is different from the dynamic stretching in 3D layers. It realizes the generation of 3D solid model based on the 2D data. So it will generate a real 3D solid model, a real 3D model. So the result is feedback to us is a new model data stored in our data source. and not the picture or not the vector data. Okay, and let's look at how to do it. It's in the 3D geographic design, and there have the stretch and linear stretch. And let's look at our exercise 4. And go back to the desktop. And close the window. Close this window. And let's look at this exercise 4. We'll use the building 1 to do it. Okay, and let's add our building 1 in the symbol data site and find the building 1 and right click it and add it to the new spherical scene. Okay, we can see that is our building 1. Is this building 1? Okay, this is our building 1, and let's do the linear stretch. And in the 3D designer, and in the button of the molding by rule, and there are the linear stretch. Okay. Oh, before we do this operation, we must to select the object. Let's click the tab of the scene and to modify it to the most to the select. And let's click the control to select its body, to select 1, 2, 3, and this, and this. Oh, click. We should to use our shift. The shift in our keyboard. The shift button in our keyboard, and okay, and click shift and to select this body, select this hole, that is hole, and then click the 3D designer and to find the linear stretch. Click the 3D designer and click the linear stretch. Okay, if we select this object, and it will appear that a selected object. So we should select this selected object. Okay, and then let's modify these parameters. Let's modify its parameters, and for the height and the height, and let's modify it to 10. Oh, height, let's modify it to 50. That is 50. And altitude, modified its altitude. Okay, and then let's select its select objects. If we check if we check this split objects and in the materials, it will have this top side and the bottom. We could select these materials. If we doesn't check this box, we will not select these materials, right? So let's select these materials, select this split objects, and select the materials. And then for the top, let's add this texture as a ground one. Click OK. And select the repeat time and click OK. And then select the side, the materials of the side, and add 0001. Okay, and it's a repeat time. The U size, we could see the 10, V size to the 20, and click OK. Okay, for this linear stretcher, let's select the selected object, and its height is 50, and altitude is the field of the altitude, and we must to check is the checkbox of the split objects, and click the materials, and modified its top materials and the side materials. The top is that the top materials is a ground one, and the side is 001, and it's the size repeat time. The U size is 10, the V size is 20. Okay, the top. Okay, and let's click OK and click OK. We can see it will generate this model data. In the workspace manager, it generates a linear extrude result, and that is the model data. It's different from the linear, from the dynamic stretcher. That is just to texture it and to give it elevation as dynamically, but in this, it is it will generate the real model. It will generate the real model. How to show the linear stretch box? That is in their 3D Designer tab of the 3D Designer. In the modeling by rule, their linear stretch. Okay, in our PowerPoint, that is our last version. That is the newest version, the 10i. That is in the 3D Designer. In the modeling by rule, it's a linear stretcher. Okay. Okay, so that is our next. That's our last. It's in Chinese. Okay, this is our first exercise to generate a model data set. If you give it elevation, and it will do some operation of the linear stretch, and it will generate the model data set. Okay, so today's course is finished, and let's summarize. So we accumulate so many of the 2D data, and we can convert it or extract it to simulate to the 3D data. So there has some methods, some ideas to do it. So first is use a 3D symbol rendering of the 2D point, line, and the polygon. And then we could make the 3D semantic map to do these operations. And we could do the vector stretch modeling. That is to give it altitude mode, give it altitude and the lift altitude. And then texture it. So that is a dynamically method to stretch. And then the next method is use 2D data conversions to convert from the 2D data to the 3D data. And then we could extract the Z value of the terrain data or oblique photograph data to extract its Z value in the terrain data to the 3D data. Yeah, we have use a 2D road and extract the Z value to the 3D road. And then the last operation is the linear, the stretch modeling. We can give it the elevation and give it a texture, and it will appear, it will generate the model data set. Okay, that is our class. And then that is our quiz. Okay, you guys could scan this code to to complete our quiz. And this quiz, you can submit it by multiple times. And if you're okay for this quiz, if you're get more than 70, I think it's a 70 scores, and that you successfully complete this quiz. And so today's class is finished. Thank you you guys so much, and we will see you in the next class.